Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer, released in 1991. Now that we are able to shoot stuff, we should start adding some enemies. One of the most simple enemies you can encounter are these small robots. They move in one direction until their way is blocked, and then they turn around and go to the other direction. They can be destroyed with a single shot. We will also implement that the enemies, when they touch us, they hurt us, so we'll also implement health. Alright, let's get into it. Let's go ahead and create a new package for our enemies to have some separation here for some organization. And let's add a Techbot class. This extends active. And as always, we need to have our constructor. We're going to have a update, and we're going to have, of course, our render functions. And then let's open up the level format. Here we are. And then let's find the robot that we are willing to do for today. So this is the purple antenna floating. This is the jumping bot. This is the tank bot, I guess, wheel. And here we have our one-to-one, one-by-one robot, the simplest one that just patrols left to right. So that is tile ID 3010. Okay, so let's go to the active factory. Let's find the spot for 310. I guess we can just put it at the top here. It's going to be a new Techbot XY. And then let's figure out which graphics for it to load. So let's open up the anim. And let's write out the anim file. All right, so here we have our robot. Seem to have 1, 2, 3 animation frames, and then 1, 2, 3, 4, 5, 6, 7 death frames, I suppose. And yeah, so 3 anim, 7 death. And then in the level format, let's see, because here we can see anim 1, so that's 50 plus 32, that's tile 82. So let's say renderer, draw tile, and then assets, get anim 82, X and Y. And then here we also have a frame. Frame equals 0. Frame equals frame plus 1% 3. And let's go here. All right, so this should add in the Techbots that are in the level. And here we go. He is in his place. He is behind the box. I'm not sure if that is correct. Probably the box should be in front of him, but for now this is okay. So let's have him patrol left to right. Okay, so patrol left to right. Or right to left, I guess. Let's go from right to left. So if there is a spot to move to, move. Otherwise, flip direction. All right, so direction tells me that we are in need of a facing. And let's say our default facing is right. And then let's make a statement here, private boolean can move to. So let's calculate the row. That is basically always tile divided by x divided by the tile size. Y, I mean, sorry. So there's our row. Let's calculate our column. That is x divided by the tile size. And then we need to figure out, like, okay, we can move into the direction. So we target column. Target col is col plus, if the facing is left, -1. Otherwise, look the other way. And we need a question mark here. All right. So return a level. Oh, I guess we need to have the level here. Return level, get tile row target column. And this should be less than 1800. Hold on. Collides. Guess we can just do our XY 1515. Sorry about that, guys. And then our target X. So int destination X is X. And then we have a movement speed. So X plus facing is left minus 8 plus 8. This is what we need to do. So this is if we can move to the left, but we also need to check if we have solid ground beneath our feet there. So our destination Y equals Y plus 8, I guess the gravity is. Hold on, so Boolean free. Boolean solid ground is level. So this should not collide, and the solid ground beneath our feet should collide. Destination X, destination Y. 1515. Guess we'll add in a private static final int speed 8, size equals the tile size minus 1. So we need to not collide in our, like, to our immediate left or right, and we need to have solid ground beneath there. So return free and solid ground. Yeah, so let me just do void try move here. If free solid ground, move to destination X, Y. We don't want to go down. So I guess this destination Y can just be this plus gravity. This should be speed. Speed. Oh, this should be size and size, size and size. All right. So if we are free and there's solid ground into our in our destination, then we can move too. Otherwise, facing equals. If it's left, go right. Oh. Otherwise, go left. All right. And then each update, we try to move. All right. I'm curious to see what our little robot is doing. All right, so this guy is moving really fast. I think they should update only every other frame. So let's go ahead and do that. So if the frame, every other frame, then let's try to move. This should slow them down quite considerably. Still moving pretty fast. So I'm not sure how fast they should be moving. But for now, I'm liking it. Okay. Yeah. So we'll take a look at the original game in a bit. But for now, let's make them hurt us. So if state get Duke touch collides with our XY size, then we should state get Duke dot hurt Duke. create method hurt. And then here we should say that our health should decrease. Let's create a field health here. Let's set our default health to 10. And let's take the time to display our health in the HUD. Let's find the health here. All right, so we might have to blink here if our health is too low. But here we should int HP or int I guess. Int I is 0, I is less than game state. Get Duke, get health. I need to add a getter, of course. So get firepower, and here, right before it, we should get his health. Let's move the health above the firepower. There. All right, and let's go back to the HUD, and then I++. Graphics.draw image assets get object. The health bar is object 61. And then we should do 240 plus the HP that we are at. And each HP tick is 8 pixels wide. Y coordinate 60, null. So this should display our current health. Let's see if it does. All right, so 10 is too much. We got room for 1, 2, 3, 4, 5, 6, 7, 8. All right, and there we saw the robots hurting us real bad because we don't have invisibility frames just yet. So let's set the default health to 8. And let's go ahead and add some invincibility. So yeah, so I guess we should just have a timer here, private int invincibility. All right, so when we get hurt, if our timer is less than or equal to 0, we should decrease the health, and we should set the invincibility timer to, I don't know, 2 seconds. So let's do 32. And we should, in our update method here, we should check our invincibility. If it's larger than 0, we should decrement the counter. Okay, so now if a robot touches us, we should only lose 1 health. So let's wait for a robot to show up. There we go. All right, there we go. We lose 1. Lose 1 again. Okay. So we'll add the invincibility blinking in just a second. First, let's make sure we can shoot these guys. So beneath here, we can say get the bolts, and if any of them... So this should be the same as for the box. So let me just go ahead and copy that. Yeah, there we go. So we should probably, as I always say, put this in a function of its own. All right, so when the bolt hits us, then let's just call our own hit function here, private void hit. And this should destroy the Techbot, but we have 7 death animation frames. So let's make a Boolean that says if it's private Boolean is alive. And then let's say private in exploding. As long as exploding is not set yet, we're alive. And then if we're hit, then let's set our exploding frames to 7. Here, if we are alive, we should draw the regular animation. Otherwise, we should draw the explosion, which starts at 82 plus 3 is 82, 83, 4, 85, of course, and plus we need to invert this explosion. So let me just see how we're going to do that, because we need to increment. If exploding is 7, it needs to be 0, then it needs to count upwards. Exploding -7, and then just take the absolute value of it. Then this should give us the frame for the explosion. And if we're alive, we can hurt Duke and be shot. Otherwise, we should just not do anything. Not even try to move. We should just do this. If we're alive, then we get to do stuff. Else, if let me see, exploding needs to go up. Let's initialize this guy to -1, so we're alive as long as we're less than 0. Else, at the last explosion frame, we should increase the score. State increase score by 100 points. And we should set active to false. All right, let's see. So I guess we should set the frames. All right. We should decrement the exploding frame, of course. Exploding -. Okay, that's looking pretty nice. So these Techbots are up in the air. They need to fall down. They are affected by gravity. So yeah. So we really should start to have a shared superclass. So let's make it fall down. So here we got some patrolling. All right. So our Techbots are running around and we can shoot them. They're giving us some points. So I think that is pretty cool. Let's go ahead and implement the invincibility blinking. And I think I'm going to reverse the explosion frames real quick. So we have speed, and then let me just private static final int, I don't know, death timer or something. Let's put it to 8 frames. And let's just initialize exploding to -1 still. And then we are alive as long as exploding is less than 0. And then otherwise, let's increment exploding. And if we're equal to the death timer, then that should be it. And then here we can just add in the explosion frames. But because rendering is afterwards, I think we should just increment the frames here in the render. So frame equals frame +1 %3, and then here we should just say exploding is exploding plus, oh, I guess we could just do ++. And then we can remove that here, and we can remove that here, and then try move is fine, render is fine, hit, and then we can just set exploding to 0. Then it'll start counting up. I think this, I mean, it should result in the same. Oh, but now, because I set it to 8, we shortly see the next frame. So I guess I should set it to 7 still. All right. Let's take these last 2 minutes to make Duke blink when he is hurt. So let's see. Let's go to the render function here. So in order to make him blink, we should only draw tiles when we should, so every other frame basically. So we could do that with an entire if statement around the entire block here. So if we are invincible, so if we're not invincible, and our invincibility frame is, or our invincibility frame is even, so either we're not invincible and then we should just draw as usual. Otherwise, if our invincibility frame is an even number, then we can draw here. And then we can just choose a different tile index after all these calculations here. We can basically just say override with the X-ray. So the X-ray is sprite number 182. So basically, if we are invincible and our invincibility counter is, because we only want to show the X-ray basically the first blink or two. So I don't know, if our invincibility counter is greater than 28, for example, then we should say that our tile index is 182 plus our facing, because it has a different graphic for left and right. So left, we should plus it with nothing. Otherwise, we should add 4. All right, so this should make Duke blink and show an X-ray, like a skeleton version of Duke for just the blink of an eye. So let's try and get hit here. All right, so he's blinking, and we do see, for a fraction of a second, we see the skeleton and it's facing the proper direction. So yeah, so it was pretty decent. Now the invincibility Boolean, I guess, is actually, yeah, basically based on this timer here. So we have some double checks. So I'm not liking this too much here. So let's just skip the invincibility check. So if we are in a high invincibility count, show the otherwise show, and then here we can just say like, okay, you know, if we're in an even frame, we should just draw, because normally invincibility is always to 0. So then this should just render during normal gameplay. Oh, during normal gameplay. So yeah. Now it should still blink and show the stuff. Let's see, let's get hurt. All right. Okay, cool. So yeah, I think that is a nice ending to our episode for today. We implemented the first enemy of many to come. It can hurt us, we can shoot it back. So, you know, it has a fair chance of defending itself, I suppose. So that's pretty nice. We did introduce a lot of duplicate code here as well. This gravity function here and this bolt check function there. You know, so I think next episode we should really take some time to find the shared code between all of these active tiles here, because camera should be shootable as well, for example. And as soon as we figured out which code we can share among all these active classes, we can maybe make a shared superclass in which we do most of the stuff, so that we prevent having all this double code. So hopefully you can join me for that one. It won't be as exciting as this one, where we, you know, add enemies and shoot stuff and get hurt. But it should still be good for the progress of the game in general. So hope to see you then. If you like this video, please consider dropping a like and a subscribe. And I'll see you guys in the next one. Bye-bye.